So this is um, just a description or a screencast, the solutions to the homework that were due on September 5th. So with that, I want to go through this. This diagram is not very good. It didn't scan very well, so I apologize about that. I know yours weren't great either. So I just want to explain the answers to each one. Hopefully you got the idea of how to do a ranking task with this example. For number one, it basically was asking this to rank the slopes in the graph. C and D have the greatest slope, then B and E, and finally A has zero slope or the least. So I looked at the change in vertical values over the change in horizontal values. Notice that D and C are parallel and B and E are also parallel. For number two, this was asking about the magnitude or the size of the slope at the labeled points. So in this case, we've got point A, points B and C, and point D. Well, magnitude means it's like an absolute value. In other words, we don't worry about whether it's positive or negative. We're just looking at steepest to least steep. So point D is on the steepest part of the graph, so that's the greatest. A is on the next steepest, even though it's negative. And then B and C have the same steepness on that part of the graph, so they are the least. For number three, this is asking about slope and not just magnitude of slope. So in this case, D is still the greatest, but A now is on a region of slope which has a slope of negative 3.5 units of x per unit, or of y per unit of x. So therefore, I've got D, then C and B are equal, and then A is the least. Because A is a negative slope, these three are all positive slopes. So this is not correct for number four. When we look at this, we've got here a distance versus time graph. And so if we're looking at the speed at 6 seconds, that means we're not interested in what happens beforehand or really afterward. We're interested in this interval in here. So the cat starts at a position of 8 meters and ends at 16 meters at 6 seconds. But if you notice, it's moving very little bit of distance during the first 5 seconds for every second of time. During the 6th second, it moves much faster, and we can tell that because the graph is steeper. So you wouldn't just do 16 divided by 6, because that doesn't reflect how fast the cat is moving at this instant in time. What we really need to look at is the rate of change per unit of time in this region, where we've got this straight, fairly steep line. So in that case, I took the slope of this line, and I got 4 meters per second. So the slope of something will tell you, the slope of a distance time graph will tell you the speed at any instant. For number 5, in this case it was asking what's wrong with this graph. Well, if you notice, this graph is scaled inconsistently here. That makes it look like a nice direct relationship, but in fact it is not. It is exponential. I think in my first period class, Jacob Ginter's group showed that very nicely this morning by drawing both of those graphs. So the graph scaling on the y-axis isn't consistent, and it misrepresents the relationship. It makes it look like it's a direct relationship when it in fact is not. For number 6, this person's statement of, as you can see, this year our popularity has grown dramatically, and we look forward to continued success, is not true. This is around 5,080 customers or website posts at the end of the year per month, and about 5,040 at the beginning of the year. That's an increase of only 40 out of 5,040. So this graph is skewed because it is not scaled from 0. It essentially does misrepresent the data a little bit, mainly by zooming in on a small part of the data. And therefore, the person's statement is misrepresenting the truth as well, since the growth was less than 1%. Number 7, the statement, our data shows that the value of y decreases as x increases. We found that y is inversely proportional to x. That is incorrect because the first part of the statement is correct. The second part of the statement is not correct. An inverse relationship is a very particular relationship. I gave you that graphical method summary which describes that, and this does not follow the shape. The first part of the statement is correct. The second part is not. 8 is correct. There is nothing wrong with that statement. It is mathematically consistent. My last period class had time to go over this today. That was a challenging thing to think about, um, and therefore, uh, make sure you understand why that is correct. So it's if X represents cars and Y represents pickups. So there are 3 times as many cars as pickup trucks in the parking lot. Well, if I pick cars, say that's 1,000 equals 3 times the number of trucks, then to get the number of trucks all by itself, I'd take X divided by 3. 1,000 divided by 3 would give me 333 pickup trucks in the parking lot. So that's correct. Number 9, I have to talk about this a little bit. If X doubles, then Y also doubles. I think B is the only one that's correct for a couple of reasons. First of all, F is going in the negative direction. So as the X value increases, the Y value would decrease. That's not quite doubling unless you think about magnitude. Because in reality, if the X value or if the Y value is getting less and less going negative, the X value should also, that would be down here. A is obviously incorrect. C, D, and E are incorrect for a little more subtle reasons. So these things with a y-intercept for C, D, and E are not proportional. We start here and we would end up at 0 of the x value with a positive y value. Well, if you double some of those things, that's not increasing proportionally. I assumed that the scale of this graph was consistent, so 1 unit of x for each distance here and 1 unit, or x for each distance here is equal to the same distance for 1 unit of y here. But even if that's not correct, this is a this is a proportional relationship. It is not a direct relationship because of the y-intercept values. In other words, if you double the value of x here, it would not double the value of y because of the y-intercept. So sneaky, sneaky. And I told you another reason why this, in my mind, f might not be correct seems to not be a 45-degree angle. That's only important if the graph is scaled in a 1-to-1 ratio. Number 10, 4 students are solving a math problem. 4abx equals cax plus 2b. I would agree with Bayon's statement the most. Really all you need to do at first is get the x terms on one side. So that is the first step to that. Mathematically, Aubrey, Charisse, and Didier, what they're saying is not correct or not mathematically correct, I should say. So what Bayon says is not the complete statement, but essentially it's the first step. So you do want to get all x terms on one side. For 11, I think this is interesting. I would say team A and B and then team C and D are close. So essentially with these, this is a little below 80%, a tiny bit above. This is more below, this is more above. All I did is look at the free throw percentages and average those out. So essentially here, I'm not looking at the number of shots made, because if I take that into account, if I just have like shots made over total shots for both of these, that could be skewed compared to these two because they may have had a different number of total shots. In other words, if Beth has played in 10 more games than Amelie, essentially it would overweight her contribution because in a single game we would assume they would each take 50% of the shots. That's a little bit illogical also, because honestly, if you have a better player, they might take more shots. So this is a pretty complex one, but I think if you take the average of the two free throw percentages, that will give you A and B on one team, C and D on another team. And that'll be the closest rankings you could have. C and D would win by a little bit. Their average free throw percentage is just a hair higher. Personally, I don't think it's probably meaningful because they're so close to each other. And finally, for number 12, this really deals with significant figures. I gave you a handout on it, but we have not discussed it in class. I would hope you would have read that. There are also some aspects about significant figures that are important with measurements, which we still have yet to talk about. So I think the thing that's key with this is if this has one significant digit and this has one and this has two, basically if it says 70 hours, that's like saying, between 65 and 75, 300 feet deep, between 300 maybe, or between like 290 and 310. Here, between maybe like 1450 and 1550. And there are other ways to think about those as approximations. So you wouldn't have things which are very general numbers result in a very specific prediction. That's far too specific, and this is far too specific. 350 hours is reasonable. It goes to the tens place. That is the same place as the number up here. So it's an estimate. So for sample free response question, I've got my answers here. I'm going to scroll through these. Hopefully you do these in class for Thursday, but I will give you a rubric. I think that this is not something I needed to answer the question, so I don't think that's great. I didn't read very carefully. I think my procedure is reasonable. This is the key thing to reduce uncertainty. That's an easy answer. What do? More trials. Your procedure doesn't have to be identical, but it should be something to actually perform the experiment. It's listed up here, testing whether or not the swing time changes with angles above 30 degrees. Down here, 4 lab groups decide to test the hypothesis. Here's the answer for this data. It does appear there's a trend. Here there's a strong trend. Here there's a strong trend. Here there's a strong trend different. Here there's a fairly strong trend. In other words, these are more than just measurement uncertainties. The average also increases, but not as strongly due to group 3's odd data. So I made the correct choice, and then I gave a specific reason relating back to that choice. Here, for part C, looking at the data, I notice an inconsistency. What is it? Well, group 3. Its times go down as angle increases. The other trends go up. So that's all I really need to answer. A plausible reason might be that the group measured from horizontal instead of vertical. You can come up with a different reason. It just needs to be plausible. Here, student A claims that the inconsistent data is because the group used a different mass. Student B claims the inconsistent data is the group using a different string length. I'm refuting one of those. I chose student A. The reason that that is incorrect is because here we had multiple groups in our class perform trials that showed the amount of mass did not affect the time per swing. So therefore, changing the mass would not have affected their results. Now, I wouldn't think they would change the mass within measuring different angles, but even if they did, it wouldn't matter. The same way, while length would affect things, I would assume that they would use the same string length for the entire experiment for group 1, 2, 3, and 4. So in other words, each group would at least have one length of string. You should not be changing multiple variables at the same time. In this case, all the groups were supposed to change was the angle. So hopefully those things help prepare you for your test. I'll talk a little bit about that more Thursday in class. Thanks.